A number of years ago, the state of Minnesota, they set protective standards for sulfate in water to protect the wild rice. If you go over to the western side of the state along the Minnesota River, you're looking at sulfate levels of as high as 600 milligrams per liter. And we have a handful of cities that have levels that are 50 to 120. And then the question becomes, how do I take that water that's 120 milligrams per liter and bring it down to 10 milligrams per liter so that it's friendly to all the wild rice waters? And in the process, it was proposed that, well, the real solution here is to use reverse osmosis. And when you start looking really hard at reverse osmosis, it's an astonishingly expensive solution to the problem. Researchers at NRI are currently working on 2 or 3 projects at which we're attempting to remove sulfate from water to address different parts of this problem. And the one we've got behind us is a pilot trailer.
This wastewater that comes out here that we're using as the influent for our system has already been treated by the facility and is ready to be discharged. But we're kind of taking it that extra step further by treating the sulfate, the dissolved sulfate that's in the water here, by this precipitation method.
Sulfate is dissolved in water. In order to remove the sulfate from water, we would like to add one chemical to react with the sulfate to produce the particles.
And then we take what's called a flocculant to clump those solids together into bigger pieces. And then we collect that and then also do a final filtration step through these big filter columns.
So this process is basically operation cost is relatively low, and it is easy adapted to the current equipment available for the plant or for some industries.
One of the things that really kind of jumps out at you is that everybody's puzzled by what we're doing. And what that tells you is that there aren't a lot of states out there that are trying to control sulfate discharges, which means we don't have technologies that are capable of controlling sulfate to 10 milligram per liter before we discharge it into the biosphere. That's become a real headache for the state of Minnesota, because if you don't have a technology that's targeted at sulfate, then you end up going after a sledgehammer. And in that case, that was reverse osmosis, which turned out to be really expensive. So what we've come up with is a number of a little more elegant ways of doing this, but they're new. And because they're new, you have to pilot them, and you have to go out and take them around to different natural waters, not laboratory waters, and verify that they will, in fact, do what you want them to do consistently without a lot of tweaking.